All right, we're going to try to finish the problem that we started in the previous video. We're going to do number 244. We're on part D, actually. But a little setup before we get there. We're dealing with parametric equations of a line segment. That's what part D wants us to do. So if we take the point P and Q, or points P and Q, as x, y, z for the initial, so x naught, y naught, z naught for our original point, and our terminal point will be Q, so we'll use the subscript 1 for those three. All right, so if we get vectors from those P and Q, those would be from the origin. We note that, and we calculated this before, our PQ, our vector PQ, which we called V, is going to equal our terminal minus our initial. Now we can rewrite this. We're going to create the vector R there, and it's going to equal our original position vector plus that t, that constant t, times the vector that we get from the 2. So times our v, or this PQ vector here. Using the properties of vectors, we can rewrite this. So this is just this is our formula here, and we've broken it down into components below. And after a few steps, we're left with that R equals 1 minus t times our position vector P plus that same t times our position vector Q. So we note that if we put in t is 0, then we have R as P. And when t is 1, we have R is equal to Q. So we're going to be left with choosing a t between 0 and 1 inclusive, meaning including 0 and including 1. Let's try to put this to practice. All right, so we want to find the parametric equations of the line segment determined by P and Q. We're doing part D here. All right, so I'll change colors here. We'll go to D. All right, so essentially we've got this R equals, or vector R is going to equal our original value, so I'm going to call that just R naught, plus t times our vector v, which is PQ up here. So we've got 3 points to consider. We'll look at our x. So x is equal to our original x plus some t times our x1 minus x naught, which we actually already solved for. Already got that down, but so our original is 4, and the subtraction of the 2 gave us -2, so -2, which means that x equals 4 minus 2t. That will be the first part of this. For y, no, let's ignore that, and let's just go straight with the numbers. It's not. All right, so the original there is going to be just 0. Our second value will be 0, and then our vector yields 3, so plus t times 3, which means y equals 3t. And our z, our original z was 5, and then our vector gave us -4, so 5 minus 4t. And these are going to be the parametric equations of just the line segment determined by our 2 points here.